Hi everyone, this is Kerim Baran with SolarAcademy. I am here today with George McClellan of REC Group. Hi George, good to have you.
Good afternoon. Thanks for having me out, Karen. This is a wonderful opportunity.
Thank you for being here. And today we're going to talk about REC's HJT technology in relation to its new offerings. But before we go there, George, I want to talk a little bit about you, your background. I've looked you up on LinkedIn. You very interestingly have studied aeronautics in college first, and you've worked in a number of jobs, but you've been in solar close to probably 2 decades, if I'm not mistaken, and you've really worked deep in solar module production and technology. Can you tell us a little bit about that background as
Yeah,
far as you want to go and how you
yeah,
ended up at
absolutely.
REC? Yeah.
Yeah, absolutely. You have done a little bit of homework. I appreciate that. Actually spent years in the Air Force, spent 7 years in the Air Force, and that's where my aeronautics degree came from. Once I left, when I got that while I was active duty, I got out of the Air Force and was working with in semiconductor production and moved from on in that and moved on to actually moved on to Sandia National Labs, where I was in fundamental device design, research and development, and which was really cool stuff. At Sandia Labs, you have the best toys and a bunch of just absolutely brilliant people. But
Was after having worked at Intel, right?
this is so I moved from Sandia to Intel. So
Oh, okay.
Sandia was great, but it's I needed to do some other stuff. So
Yeah.
moved into worked at Intel in process development. And once I've been working there for a while. My daughter had gone off to college. I was an empty nester, and some friends of mine had gone out to this new solar startup. This is in the early 2000s. Gone out to this new solar startup, and they said, "Hey, I think we've got a position for you out here. Why don't you come out and check it out?" And if you think about the early 2000s, where you got people to work in solar, there was no schools, there was no training on it. So you just found someone who knew how to work. So this is solar panel development, solar cell development. You find someone who knows about processing silicon.
Yeah.
And so we just grabbed a bunch of people from the semiconductor area. So, Intel, some of the manufacturers. So that's where it came. So I went to work for a company called Advent Solar, which was great. It was a good opportunity. Product just we were doing it was a back contact cell on polysilicon, which is very similar to what SunPower was doing at the time, only they were doing it on mono. Because we were doing it on poly, we couldn't do it at the same efficiencies. And because we were a startup, we certainly couldn't do it at the same cost. So our factory gate costs were like $4 a watt or something like that. So not the best technology, but it was great. Good experience. Learned a whole lot there. Learned how to build a factory. Learned how to, we did some great stuff. But I moved from there over to REC in 2009. So REC was, and yeah, the good part was there was lots of opportunity in solar at the time. If you wanted to go somewhere and do something, you could probably find a company that you would work with. REC had a very good reputation. They were just coming to the United States, and it looked like they had a good product, and they had good backing. So if you think about the early 2000s, 2008, 9, 10, there was you think about all the companies that were out there that are gone now, whereas REC is still stuck around. So
Yeah.
they were doing some things right. It was a Norwegian-based company. The Norwegians have got their geniuses when it comes to strategic long-term plans. So I realized that was probably going to be a good thing. Started working with them, became their technical manager for the United States. There's one of me in every country, well, not every country, but all of our regions.
Major.
And it's got them in APAC, you've got them in Australia, you've got European, you've got Eastern Europe. So and the good part about this is that we answer it. So with the technical department, we answer questions. That's our job.
Hmm.
And we interface with the customers that have questions. It can be everything from, why is my warranty taking so long to, what is your dopant regions? What is your dopant levels on your cells? It can be just it leads to a very broad knowledge base, and you have to be able to share that with the customers in a way that they can understand that.
And
Um,
these customers that ask these questions, are they utility scale developers? Are they residential solar installers? Anything in
Yeah.
between?
They're just about everything. It's everything from a homeowner who has a 5 kW system on their rooftop to a CTO of a multinational company that's just bought 600 megawatts and wants to discuss the finer points of a cell adhesion or something. So you have to be able to talk the language of just about all of these people. Mostly it's working with installers who are trying to understand either mounting or installing products. What are some of the issues there? I work a lot with the sales teams, trying to figure out what are the finer points, what are the unique selling points of our product. A lot of performance modeling and just understanding looking at the competition, what's out there, and how do we compare. There's a lot of good stuff out there as well. So, we're not going to say we're the only game in town, but we are. We're a very good product.
Understanding what their products are, how they are designed, perhaps
Yes.
reverse engineer some of that and incorporate it. And
absolutely, there's a lot of good stuff out there.
Yeah, makes sense. Before we get into REC and REC's unique offerings and technology, I wanted to take this opportunity, George, to talk to someone who's been in this industry for close to 2 decades, plus or minus, and who's been deeply in the technical aspects of solar modules. Maybe talk a little bit about the evolution of solar panels over the past decades.
Yeah. Absolutely.
Can you give us a primer on that? I remember going as far back as 2009. There were thin film companies like First Solar, and there were multi-crystalline options like many of the other companies in the market, like REC and Q-Cells and Canadian Solar. And I know the basic differences between them, efficiency-wise and price-wise, but so much has evolved since those days. So maybe can you give us categorically how these things have evolved and where we are in history? And
absolutely.
Obviously the Swanson effect is in full force in effect right now. Prices keep coming down, and panel prices have gotten probably 7 to 10 times cheaper in the last 14 years or 15 years that I've been following. So let's dive into that a little bit.
There's been so yes, it's been very interesting because I've got to witness an incredible evolution of an industry. If I think back when I first started, we were doing 5-inch wafers. Our big goal was, do we make a 50 cell or a 60 cell module? We didn't even know. And that was 2004 timeframe. But we were excited because we were making a 135 watt panel, 60 cell, 135 watts. We were spiking the football. We had done it. So this all starts. So there's a couple of different things that you look at. There's the technology, and then there's the format. So one is there's cell technology, and then how are you gathering? So the cell is going to be where you're gathering your charge, but then how are you gathering that charge there's a couple of differences there. So we've gone from, you mentioned earlier, so we've gone from polycrystalline to, with the monocrystalline, we've moved. So the polycrystalline took us up to about 18-19% cell efficiency. And then what you do is you just run out of, you take the material system as far as you can go. Now you've run out of headroom. You have to change that material system. So what do? So you jump up to the next technology, which is mono, and you've got P-mono and N-mono. And that gave us a good jump up to, 23-24%.
That jump happened circa which years are we talking?
So the moves to mono that was 18. So the industry was still trying to work. So you have to stay as long as you can on your current material system, because nobody likes change, especially in the process areas. So you're driving a lot on poly. You start doing some tricks with poly, things like doing some backside coating. So your PERC came in on poly cells. About 2016, 2017, the industry really started to push into monocrystalline. So now you've got monocrystalline, which gives you better efficiencies. But if you press the poly, if you do all of your tricks on the poly, you can get close to that monocrystalline efficiencies. So that's why you were seeing things like the big push was going from up to a 300 watt module. So REC was making a 290 watt module with poly PERC or poly cells with a PERC background, but the industry had shifted up to, oh, we need 300 watts. That becomes there's always these little, I mentioned earlier, 135 watts. Yay, that's great. But there's always these imaginary lines that you have to cross to get acceptance in the industry. So there was this talks about it there. So yeah, we're in the second section there where the 20 to 22%. So you're going into P poly, P mono, but so we made a poly PERC product, which got us up close to 300 watts for our modules, but we just couldn't get over that 300 watts. So then, to get up there, you have to move to a newer type of mono, and that's when you move to N-Mono. So this is moving into N-Mono, started happening a lot in the industry, 2020 timeframe. And then the whole industry is really pressing towards that. Along with N-Mono, so there was standard N-Mono PERT, but then they introduced TOPCon a couple of years ago, as well as HJT. And so that takes us up to kind of where we are currently. There is a very big push on getting everything we can out of these N-Mono platforms, TOPCon and HJT, because the next level of technology is introducing tandem junction and Perovskites and things like that, which will change. So those are notoriously difficult to work with. Difficult means expensive. And as you mentioned earlier, the prices for solar modules are just going down. So nobody wants them to go up, but everybody wants more power.
On that note, I'm going to plug in our SolarAcademy charts section here and show the first chart we put in the chart section is the Swanson effect.
Yeah. Holy cow.
There it is. 1977 price of $76 per watt. This is the cell pricing, which is now, this chart is only to 2013 at 74 cents, which is now probably in the 20 cents, if not, depending on the market, plus or minus probably. But yeah, that's at the cell pricing, of course, not the final product, but still incredible, hundreds of times cheaper. So I'll take that away now.
So nobody wants anything to get more expensive, but everybody wants more power and wants everything to stay exactly the same. Now, the interesting piece about this evolution, as I mentioned, is not just about the technology, but it's your current gathering and your cell architecture has also played a big piece into this. So in 2014-15 timeframe, half-cut cells were introduced by REC. And the reason you do half-cut cells is to reduce your resistive losses. Your resistive losses come down as the square.
Do you have a slide on that over here? Should I pull anything? No.
Don't have any of the half-cut cell stuff because that was this is just saying that the timing of all of this also coincided with technology changes. So you've got not only you're introducing N-Mono and P-Mono, but then you're doing half-cut cells. You started increasing the amount of bus bars that run on the front side of your cells. You started doing your backside passivation. So there's a lot of things that are going on, not only just cell technology or not just material systems technology. And all of this is in response to the customer's insatiable demand for more watts peak at STC. So all of these things combined are driving up cell efficiency, but also module efficiency and driving up your peak power of these panels. Right now we're up in the 470 watt is what our current residential offering is, which is just I think about what we've started out with, and it's just amazing.
Is that the same format in terms of height and width or length and width?
That's
like the good old early 2010s. I remember, like we had 200-watt panels, or 225 was kind
Yeah.
of like the biggest wattage
Yeah.
back then.
So the interesting
Same
piece
size?
is solar panels have always been rectangular in a kind of a pretty much a 1:2 aspect ratio.
Mhm.
And from about 2010 to about 2016, we were so close to standardizing. We had 60 cell
72 and
panels, we had
60.
72 cell panels, and that
Yeah.
was it. And they
Yeah.
were all 990 wide, 990, 990 millimeters wide by 1776. Just
Yeah.
everything was within a couple of millimeters. It was so great.
Yeah. I
Uh,
remember.
that's one of the things that I really could not understand in this industry when I moved to it. There's no standardization. And
Yeah.
if you go back to how did computers get so cheap? I mean, the very first computers I bought my daughters were $5,000.
Yeah.
And they were, it wasn't. So then that was back in, 1998 timeframe. So 1996 timeframe. So how did we get cheaper to where you've got these fantastic computers for $600? It's all about standardization. So volume and standardization. So, but here everyone's just a little bit different. As the industry decided to change, and the industry is driven by the customers, we've gone to demand pull instead of technology push. It used to be, here's what you get, buy it. Now the customer is saying, no, this is what I want. And so we're actually fulfilling the customer's needs with technology pull, or with demand pull. So they want more power. We're trying to give them certain ways of getting more power. That's where half-cut cells came in. That's where N-Mono came in. And we still stayed with 60 and 72 cell formats until probably 2 years ago, and then things just started going a little bit crazy where everybody wanted a 400-watt panel, so they just started adding cells, which made your modules bigger. So that doesn't all that that doesn't that's not technology. That's just adding more X's and Y's.
Do you think that is being driven because the sales guy at the installer wants to say, "Hey, we got the bigger pan," like it's like that?
Yes,
Yeah.
absolutely. So I
But
like to.
that's little bit sad in a way
It's
because
it's very sad because what matters
yeah,
is kilowatt hours per kilowatt peak. That's all that I know on the
of
customer's
course,
invoice, it says
yeah,
kilowatts, but what the
right.
customer is buying is kilowatt hours.
And maybe kilowatt hours per square foot or square meter
Right.
of panel
Yes.
space you put on the roof or on a specific uh,
Absolutely.
space.
Yes.
So
Yeah.
yes, I totally agree. Having developed solar farms and put
Yeah.
solar on my home, I get the math.
Yeah. So people are looking at, kilowatt. People are looking at, I just want more kilowatts because, their neighbors got an 8 kW system. They needed 8.5 kW.
Yeah.
And it's kind
But
of like,
there's a few layers of high school physics that people need to remember to do that. And even my friends with advanced masters and PhD degrees, I see them just not putting in the time to understand
Mhm.
that extra level of calculation and math.
Right.
And so that's why the panels are getting to be slightly bigger in size,
Right.
and we're not
So,
standardizing on a specific format and just kind of
and
setting.
it's going to change even more in the next 18 months to 2 years.
Wow.
What I liken it to is when people are buying a car, they look at horsepower.
Right.
Horsepower doesn't really matter. It's miles per gallon that matters. But everyone wants, oh no, I've got
Ask
300
that to my
miles.
17-year-old boy. He might
Exactly.
say different.
Yeah, I know. But what really matters in the end is miles per gallon.
Absolutely.
But
Absolutely.
you hit on a really interesting piece. In the past couple of years, things have started to get a little bit crazy with module formats. So
Sure.
one of the things is solar cell sizes are changing. We are, currently, so we've moved slowly from 156. So we've moved from, M4 to M6, M6 plus. So we moved up 156 millimeter, 162 millimeter. And the cell manufacturers have realized that to make a solar cell, it costs the exact same amount of money to make a 162 millimeter cell as it does to make a 210 millimeter cell.
Is that because of the way it's cut in circles
It's
or
just
some shape?
so yeah, you're pulling an ingot, you're drawing out a boule, and the size of that boule really doesn't matter. It's not as the cost of pulling that boule a little bit larger is not as significant as it is. It's a second order effect when it comes to the cost.
Yeah.
So now they can pull these bigger boules. They can make the G12 cells or the M10 cells at the same price as making an M6 plus cell.
Yeah.
So why would they make an M6 plus cell when they can sell it? They can sell a G12 for more profit. So what's going to happen is those M6 plus cells are not going to be manufactured anymore. And that's why there is this preponderance of G12s and G12R and M10 cells on the market right now, which are bigger. They're 210 millimeter wide cells. That changes the format. You just can't, it changes your electrical layout and it changes your physical layout. So you have to, and that's changing everything in the industry. Our new products, we've got a 44 cell product right now. That's
what's the wattage on that?
So that's your, we have a 44 cell product that is 470 watts. That's the Alpha Pure RX series. What's interesting about the Alpha Pure RX is that the cells are run, because the cell size, we have to run the cell strings on towards the short side, parallel to the short side, as opposed to most modules you can see in the background here of my video, they're run parallel to the long side, which changes the location of your junction boxes. But lots of companies out there are getting very creative on how they are going to put their product together to try to maximize power, but also have something that can be installed. Because ultimately, our new product is actually shorter and wider than most products. It's 44 inches wide or 48 inches wide, which is, 6 or 8 inches wider than most panels, but it's also shorter. It comes in right at 50 pounds, just under 50 pounds. So, I mean, there's lots of things you can do. You can have a 700 watt module. It's just going to be really big.
Yeah.
So there's going to be a lot of cycling around between all of the manufacturers as they move to G12 and M10 cells over the next 18 months. Watt classes will go up, but you're going to get to a point where, it's just going to be, so with utility scale, it's going to be, I think it's going to be brutal. They'll have 8-foot modules out there, but they'll also have, 750 watt modules. It's crazy. So that's almost 1 horsepower. If you think about back to your high school physics, it's almost 1 horsepower in a single module. That's crazy.
That is, yeah.
So that's pretty cool. So, but anyway, that's what I see is going to be happening with the evolution of product right now, because we've just got, there's a lot of things changing, and they're not changing because we want them to. They're changing because the customer is demanding more power, lower costs. And there's only, you can't, it's one of those, it's the triangle there. You can't change one side, everything else changes as well.
I mean, you having been so involved in this segment of the value chain, I would love to do a side conversation one day with you on what your personal views are on whether we should bring standardization and how. But that's a conversation for another day, maybe a future solar conversation.
I've got some unique views on that.
Yeah. Well, maybe we can tag it onto the back of this one.
Yeah.
But for now, I want to go into a little bit about where REC is in its current innovation curve offerings. And let's talk a little bit about the new HJT technology and the benefits it brings to the market today.
Absolutely. Yeah. So as you mentioned, we've got a couple of products in the market right now. We are still manufacturing a N-Mono TOPCon product. That's the NPEAK 3 series. Great product, coming in about 400 watts, 420 watts. But what we are really standing on is the HJT product, heterojunction product. And that's the Alpha series. So that's the Alpha Pure, Alpha Pure 2, and Pure R series and Pure RX. So those products are, they're all HJT. They are on two different size cells. So the Alpha and the Alpha Pure series are M6 Plus cells. The Alpha Pure R and the Alpha Pure RX are actually on the G12 cells, which again causes a shift in the way that the cells are laid out. It's a very functional product. It's great. It works well for residential as well as C&I because it does have up to 470 watts. So it's a good player for the C&I. It's also not huge. So there's a lot of products out there that are they're 500 watts, but they're 7 feet long, which that messes up ground coverage ratios pretty bad.
Of your total offerings, how many key main SKUs do you currently have, from the resi to C&I to utility offerings, and how does the various technologies play into that? So
That's good.
HJT is not a utility solution, right, these days? I
Yeah.
assume there must be a reason for that.
That's a very good question. Right now, so our product, so in order to reduce the amount of SKUs in people's warehouses, we moved to a -0 plus 10 watts binning strategy. So we just manufacture 400, 410, 420. And say our Alpha Pure series is 400, 410, and 420. That's it. We don't do 400, 405, 410, 415, which has been accepted and preferred by the installers. It used to be everybody always wanted, just give me that extra 5 watts. I can sell on that. But it's easier for them to just say, nope, it's going to be a 410 or a 420. And that's what you get. And so that's across all of our Alpha Pure and Alpha Pure RX products. So the Alpha Pure will be, we've actually manufactured the last one of those. We're moving up to the Alpha Pure 2. So that's one product line with 3 SKUs. The Alpha Pure R will end of life soon, and we'll move to the Alpha Pure RX, again, which will have, it'll be 450, 460, and 470 watts. So again, 3 SKUs for that. Later this year, we will be introducing the Alpha Pro M series, and that is it's a 640 watt. It's actually it's G12 half cut cells in a different layout. So it's actually a larger module, but that will be coming. That's our basically we're planning for that for C&I. Some people may want to stick it on a rooftop, resi rooftop. It's a bit bigger. Well, it's a lot bigger, but that will be our foray into C&I, as well as it can be used for small utility, but it is not a bifacial panel. It doesn't have a clear back sheet. That will be coming out probably within the next 18 months, a clear back sheet, as we move back into the utility scale space.
So talking about these various different technologies, I'm going to go share my screen again to summarize the differences between all these different products that we're talking about. So going back here, George, if you can give us a little bit of a summary on the various different technologies that are out there right now.
Absolutely.
Like what are the differences between, for example, P-Mono and N-Mono offerings, as well as TOPCon and HJT, and maybe compare them to PERC and PERT
absolutely.
as well. Yeah.
So this is all, things have all been, so we're always looking for a better way to do things in an industrialized setting. A lot of this stuff has been around for a very long time, but it's really, how do you commercialize these things? So the easiest to commercialize was a polycrystalline product. So that's a P-type polycrystalline product with aluminum backside field. That's what the BSF is for. That's your standard product that was made from the 70s up to the early the mid 2000s. We started moving into monocrystalline products, which is a more purified single crystal product wafer in the 2010 timeframe. We also started introducing backside passivation processes. That was the introduction of PERC which is for passive emitter rear cell. And then the follow-on to that was PERT, P-E-R-T, passive emitter rear totally diffused. So similar products, but what that does is increases the efficiency of the cell by using a backside treatment of the cell. Now, as we got more sophisticated, we moved from P-mono to N-mono, and the difference there is the bulk material is either positive or negative. You've got the bulk material is charged one way, and then you put your PN junction on top of that, and that's where you generate your current, is across that PN junction. So if your bulk material is doped with a positive dopant, so silicon is a semiconductor, it's neither positive or negative. You can turn it one way or the other based on the dopant or the impurities that you put in it. So if you put boron in that in a silicon ingot, you'll end up with positive or P mono. The problem with P mono is that it is subject to light-induced degradation. So that's LID, which we've all heard about, but that's your degradation that happens in the first 50 cumulative kilowatt hours of exposure to the sun. And that is caused by boron oxygen defects. So we moved from using boron as a dopant to a negative dopant, which is phosphorus. And now that gives you a N-mono product. If there's no boron, there can be no boron oxygen defects, which means there can be no LID, which now you've just gathered another 1.5 points of efficiency. You've reduced your degradation of your product just by moving over to this material system, this N-mono. Wow. So now you have your N-mono product, which is going to be more efficient and is not subject to LID. So now you've gained efficiency and you've gained power without having to spend too much money, because you can make super efficient stuff. It just costs lots and lots of money. So the goal is to keep the cost down. So then we started doing backside treatments on our mono products. We introduced PERC and PERT to mono, but a few years back, tunnel oxide passivation, so that the rear coating on the back of the cell was done by tunnel oxide, which is even more efficient than your PERC and PERT.
So that's the TOPCon technology.
That's TOPCon, and TOPCon is very good, but it still is not changing things. So it's a backside treatment. We moved to HJT, which so here is basically this is
that's the latest and the newest and the most current.
This is the most advanced. Well, the interesting piece about HJT is HJT has been around since the early 2000s. It was originally manufactured by Sanyo. That was their HIT product. They copywrote it as HIT, so that's why no one says HIT. But the Sanyo product was using HJT, as well as the product from Panasonic bought Sanyo. And if you remember, they used to be very powerful products, but they were also twice as expensive as everything else. REC figured out a way to make the HJT cell without the excessive costs, and also came up with a new type of interconnect. So, and this again is for our desire for more watts peak. But you can see what it comes down to is it's basically a sandwich. You've got a N-mono cell in the middle there, and then you've got a silicon layer that goes on top of the N-mono, on the top and the bottom of that cell, which now increases the spectral response of that cell. So the cell now is responsive at the regular N-mono wavelengths, but also the amorphous silicon on the bottom and the top of the cell. It also responds to those wavelengths. So you've increased the spectrum that your overall cell is responsive to. So, and one of the good parts about this is that it has increased the sensitivity on the long end of the spectrum, so around 1200 nanometers, that's where your red light is. And if it's turning that red light into energy, watts, not temperature. So it's not dropping this. So what it does is that infrared light comes in, hits the cell, they turn that into current as opposed to heat, which brings down this.
Is this the difference that it results in?
And this is one of the differences here. So this is an annual production of an array. This was modeled. This is an 8 kW array in Palm Springs. But you can see that the energy yield, because we've got more energy, is being transferred into more photons are turning into current as opposed to heat. And so, yeah, this shows a higher production because we have a better thermal coefficient for our product. And that's one of the benefits of HJT. So if you compare this to other products out there, lots of people are looking at, well, what is the bifacial rate? If you look at the way that the product is made, you can see it's like almost a perfect sandwich. So the bifaciality rate of an HJT product is almost 95%, where if you compare that to TOPCon and even PERC, if they try to make a bifacial product, they will work as bifacial products, but the bifaciality is lower for these other products. And that's just cell architecture. Your efficiency is significantly higher. The degradation, again, by protecting your products, also having an N-Mono product, your first year degradation is going to be very low. Annual power degradation. And
that's incredible. So I'm looking at that. That's 0.25%. So right. Do you guys then write warranties that promise like 93% plus at year 25?
92%.
92? Okay.
92%
wow.
At 25 years, which is just, I mean, if you think about that, 25 years of nameplate value, or 92% of nameplate value after 25 years is just incredible. I mean, what's out there that's going to last 25 years and also be able to provide 92% of that nameplate power after 25 years? Just incredible. And we have things coming in from the field that are showing. So this has been one of the benefits of being an early adopter of HJT. We started making it in 2019. We have got products out there in the field that we do comparative energy yield analyses, and we've got products in the field, and they're meeting this, degrading significantly less than this 0.25%. So just a really fantastic product out there with respect to annual degradation. And part of that is due, again, as mentioned earlier, to this temperature coefficient, because it's turning more photons into energy as opposed to heat. So you're keeping your product cheaper, or you're keeping your product cooler. And, everyone, I think we all know that as, solar panels have a negative temperature coefficient. As the temperature goes up, their performance goes down. But the contra to that is also true. As the temperature goes down, performance goes up. Sure. So they ultimately will operate very well on a cool, clear day.
One more thing I want to make sure we touch on is the microcracks issue. I think this was the slide relating to that, right? Can you tell us a little bit about the benefits of HJT in the context of microcracks?
This is a really good image. I'm really glad that we can share this, because I thought there was some secret sauce here, but I guess it's understood by the industry. The way that HJT cells, or the advanced interconnect cells, some people call it SmartWire, but SmartWire was trademarked by Meyer Burger, so everyone just says advanced interconnect. But you have connecting the cells. The cells are not connected by wires anymore. They used to be connected by interconnect ribbon. And there was, they started out with 2 ribbons, then went to 3, then went to 5. and it really started getting kind of, all over the place. We've moved away from that and gone to very, very fine conductor wires that are embedded in a carrier film.
Is
And
this related? Is this slide related to what you're
yes,
talking
this is
about?
exactly. So you can see a standard connections used these 5 bus bars,
Yeah.
whereas the REC alpha pure cells used these very thin wires. They're in a carrier film.
Mm-hmm.
That carrier film is like, it's a very thin, almost a cellophane. It's a transparent, it's a TCO, a transparent conductive oxide. It is, it's very thin. It's like the stuff that you used to, the film that would wrap up DVDs, DVD packets, or
Mm-hmm.
the old cigarette pack for those that smoke cigarettes. But so these wires are carried in that, but they're all embedded in that. They're laid on the top of the cell, and then they're bonded electrically during lamination. It's a very low temp bonding.
Yeah.
So the thing here is you've got this extra layer of this transparent conductive oxide that goes over the front and the back of the cell. So that's providing another layer of protection. So you've got your cell, you've got your TCO layer, and then you've got your encapsulant on top of that, and then you've got your glass on top of that. So you have an extra layer of protection there. And what that does is provides a stronger bond between everything. So now it's a very strong lamination. The other piece is that these cells are thinner. And because they're thinner, they will bend more. They don't end up cracking. So what happens there is that you're more protected against any loads such as a installer walking across your rooftop, or hail, or things like that. These panels will actually survive better in that environment because they are better protected. It's a stronger, stiffer platform, but it's also, if it does flex, it will flex and not cause microcracks. And microcracks are a real concern because when they happen, they don't show up. They don't show up immediately. The problem happens is after a few years, after this thing is cracked, through thermal cycling, this microcrack grows into an actual real crack, separates the conductors, and now you've lost a cell or maybe a panel. So microcracks are a ticking time bomb. I don't know if I'm allowed to say that, but they are a future problem, not a problem right now. So those are the real.
Why do you think they are a future problem? Do they get worse over time?
Yeah. So
could it even cause fire or things like that?
Yeah. What happens with a microcrack is that when the damage happens, you don't know it. If you're, during an installation, if someone's standing on a panel, or if the panel got dropped, you can still check that array. It will still check out as being full power. And so the installer walks away and says, yep, I'm done. But during that, over the time, doing it because of thermal cycling, the temperature going up, coming down, coming up, your panel is going to shrink and grow. And what will happen there is that crack will turn into a full-size crack, breaking the conductors or causing a hot spot. And hot spots can cause, it's not going to cause a fire as much as it will cause damage to the system. It'll cause a hot spot, and that will cause damage to the back sheet and open up it could burn, it'll melt the back sheet basically. And if it compromises the back sheet, now you have a path for moisture incursion. And moisture incursion is bad because you'll start shorting out your system. You'll get you get arc fault, which if you've troubleshot an arc fault problem on an array, they are really hard to do because once they get wet, they short out. But if they dry out, they don't short out anymore. So you end up losing. So your system performance is going to drop off. You'll lose modules, difficult to troubleshoot, that type of thing. And the bad part is that damage may have happened 3 years ago. And so everyone's just pointing fingers. no, it's your problem, it's my problem. And,
I've recently heard of a startup just taking those fleets of residential solar assets and changing the backsheet on them
yeah.
for a, you know for a certain fraction of the price of a new solar module.
Yeah.
Actually,
Absolutely.
Yeah.
We've learned a lot. So if you think about what we've learned, how many gigawatts we've installed since, the modern era. So say 2010, how many gigawatts have been installed. So if you think about, what we did from 2010 to 2014, there's some pretty bad modules being manufactured. I'm not going to lie.
Yeah.
So the prices, if you think about price per watt, so that was the overseas invasion, price per watt just absolutely tanked. How did we get there? Did we really, is that economies of scale, or was there some
Yeah.
things happening there that may bite us in the end? And we're finding out. We're seeing backsheets fail, we're seeing EVA brown, we're seeing bad connection points, and all of this had to do with the move from manual assembly, which a lot of people were doing up till about 2010, 2012, a lot of manual assembly, to now where everyone is fully automated and has very good process control. But there's a bunch of stuff out there that is going to that we're going to be having some problem with over the next 5 or 10 years. It's an opportunity.
Do you think the HJT technology is going to come to utility scale solar as well, or is it already?
Absolutely. So that's a really good point. So utility scale, the reason that a lot of companies aren't selling that into utility scale is a very low margin business. So
You
how do
guys
you
do utility too, right? I mean,
we used
probably a significant percentage of your business is utility as well, right?
we
Or is it
used to do
mostly?
utility. We stopped doing utility in 2018
Okay.
because we were capacity limited. We only had 1.2 gigawatts of capacity, and we were selling all of that into residential and CNI.
In Europe and US mostly, I
Right.
assume, right?
Yeah.
Yeah.
So there was no need to sell into utility scale, because you sell into a utility scale project, you've just sold 400 megawatts. So with us, that'd be a third of our capacity, annual capacity, at very low margins. Now, if you're making 7, 8, 10 gigawatts, you've got capacity that you can sell off into that. And still, those margins aren't going to kill your bottom line. So we are moving into, we will be producing a utility scale product within the next 18 months, but in our factory in Jamnagar, India. But the question about will HJT make it into utility scale? I believe it will. It becomes a question of can you make it affordable enough for the utility scale? Utility scale, they really like having more power. And if you remember, go back to the slide about the benefits, the bifaciality of an HJT product is higher than TOPCon or any of the other HJT products out there. So if you've got a 95% bifacial rate, you can actually, you'll be getting more energy. Ultimately,
Probably 5 to 10% more energy than a regular.
right. And that's huge in utility scale. So then it
Sure.
just becomes an LCOE, levelized cost of energy question. So you're going to be getting more energy, but what is the cost of that energy? And if, it becomes a trade-off.
Yeah.
There's a lot of work that needs to be done on bifaciality, understanding how bifaciality really, how we can optimize bifaciality for utility scale. And once I believe that is figured out, the HJT product will become more used. I don't know what to say it's prevalent, but I believe there will be use. I mean, we're banking on it. It will be happening. We'll be selling it. That's for sure. And I think there's going to be a good market for it. But can you fight with some of the prices of some of these products coming out? I don't know. We'll see. If I'm buying something that's going to be this is a 25-year relationship. Now they're moving out to 30 years, 40-year relationships. I'm not going to go out and buy the cheapest product out there. There's a couple of things you don't want bargains on. You don't want to bargain on, brain surgery and tattoos. Those are the things I'm not looking for the lowest cost on those things.
Yeah. And you having worked at REC for 14 years, now, if I were buying from REC, I would feel good that somebody knows why certain decisions were made the way they were. And that comes through in this conversation. So thank you for that. With that, can I ask you a little bit about what is to come in the REC offerings over the next months, quarters, years?
Yeah,
Is that
absolutely.
something we can talk about in this conversation?
I like talking about those. So as I mentioned earlier, we've got the Alpha Pro M series. That is a product that is going to be coming into the US probably December. It is a 640 watt product. And that's going to be targeting CNI and small utility scale. We see that in up to 2 megawatts, ground mounts, targeting ag, things like that, and then also CNI rooftops. It's a monofacial product because you don't really need bifacial in CNI space. People like to have it, but I mean, really, what are you getting with a bifacial product that is mounted coincident with the roof? You're really not getting much bifacial gain. So we feel that we'll have good penetration with the Alpha Pure M series in CNI, and then some small utility scale ground mounts where bifacial gain really isn't that important. We'll be introducing the Alpha Pro L series, which is also an HJT product using half-cut cells. And that's going to be up to, I believe that's 740 megawatts or 740 watts product. It's a bigger product. It's 2.3 meters tall. So yes, that's big, but that's what you get when you string all these things together. But that is focused clearly on utility scale. And that's got lots of things. So it'll be a glass on glass product, but it's 1.9 millimeter glass, so it's not going to be as heavy. So that's the big dig on glass products right now, is that yes, they've got a very good warranty because they've got no backsheet on them, but man, they're heavy. So you reduce the weight of that by doing thinner glass. You're mounting on a single axis tracker. So you're mounting on the torque tube. And so now you've got to have, if you've got a longer module, you're going to have to, it becomes, big problems with the drive motors and things like that. But the people out there at Nextracker and ATI, there's a lot of very smart people out there that are learning that will be there for, they'll have a solution in time. But yeah, we expect those to be coming out. Moving farther down the line, I think lots of companies are looking at perovskites. Perovskites will be it'll be a tandem junction. So there'll be two PN junctions on the cell. And that will give you, again, it's our lust for more power, more watts peak at STC. So that'll give us even higher, 850 watt panels, that type of thing. But I think a lot of people in the industry understand the limitations of perovskites. So they're not as reliable, or I don't say reliable, they're not as robust as we would like for them to see.
Yeah.
So they're, they degrade in sunlight. They degrade when they're outdoors and in sunlight. Well, that's just not a good match for solar panels.
Yeah.
But they're working. There's some very smart people working on that. And just about everybody has a solar perovskite plan in their future for when that happens. Short term, what I see is happening is where we will actually, so the arrays will be built with the perovskites on them. the perovskites will add, 10%, 12% power to that panel, but they'll only last for 10 years. So then
10% to the 23%, so like another 2%.
10% in watts peak. So it'll turn a 800 watt panel to a 900 watt panel.
Oh, wow. Okay.
So it will drive that up to 900 watts, but it only lasts for 10 years. That perovskite layer will only last for 10 years. So after 10 years, it degrades down to an 800 watt panel again, which is a lot of power.
Yeah.
I think that's the way that perovskites are going to make their entrance into solar, because I don't believe that we're going to be able to make something that's going to last 25 years right now. But that's coming. Or it's not even perovskite, it's perovskite-like film that we can add to that. So but I think everyone's looking at perovskites. REC certainly is. I would expect that's going to follow HJT. And then there's, who knows after that? There's lots of good stuff out there.
We've already done a conversation with Scott Graybeal of Calux, which is a company associated with REC. I believe you guys are a investor, if not the parent company of Calux.
Yeah, it's common knowledge that we've got an investment in Calux, and they're doing great work down there out of Pasadena. They've just moved to a new facility, and they're doing what's called a 4T. So what they do is they put perovskites on the front glass, and they take that's one solar panel, and then they bond it with the other solar panel. So now you've got two panels, which you've got 4T, 4 terminals, and you just join those two together, and that's your output. Pretty cool stuff. I believe that's 4T is probably going to be the most effective, as opposed to putting perovskites directly onto solar cells. That's a bit more elegant, but it's also it's showing to be a bit more problematic.
Come close to the end. Maybe I should ask you just generally what you think of REC. You've been there for 14 years. You must have some good thoughts of the company that, it's rare to find someone who stays at a company this long these days. So maybe you can tell us a little bit about what makes REC special and unique for you.
Yeah, that's I would appreciate that. Yeah, I like the idea to let you know a little bit about REC. So the interesting piece with REC is I mentioned earlier that they do have a very good strategic vision, and that's part of their Norwegian heritage. I've spent a lot of time in the Singapore so we manufacture in Singapore. Spent a lot of time over there providing help with the factory, doing factory tours with our customers and things like that, providing audits. The team over there is very, very focused on quality, and that's one of the things that comes through in our product. I always people say, well, you've got a great product, and but how do you prove that? Well, I'll tell you how we prove it. You go to look at our in-field failure rates, things like that, which are second to none. We've got an in-field failure rate of about 60 parts per million, which is about one module for every 15,000 is failing out in the field. But this all starts at the lowest level. So you can go into our factory. Everyone is just one of the reasons we're in Singapore is there is a fantastic workforce there that is very focused on quality and just doing Singapore is interesting. The group there, they're kind of fatalist. Everything has to be going wrong for them to feel good. And so they love to solve problems, always to make sure, if it's going good, there's got to be something wrong. So it's pretty funny, but everyone really focuses on just making things a little bit better, a little bit better. They're not out to hit home runs, but they got a lot of base hits, a lot of singles, bang, 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 just turn the crank. It's nuts and bolts engineering. Like I said, I came from Intel Corporation, and they're, fantastic at just incremental improvement. And that's what REC does. They're not looking for the white knight. They're not looking for the home run. It's just turn the crank, get it done, get it done. And it's really interesting because I was over there once. I was doing a factory audit with Clean Energy Associates. They're coming over to do an audit of our factory, and I'm walking around with the inspector, and he goes, "Well, George, this looks really good, but are you sugarcoating anything or that type of stuff?" I'm like, "No, that what you see is what you get." He goes, "Okay." He went to one of the technicians, and I can't remember what it was. I think it was solder gun temperature or something. He asked the technician, he goes, "Well, how do you know that solder gun temperature is correct?" And the guy was so excited. He's like, "Let me tell you." And he went right to the book. He went to the exact page in the book. "Here's my calibration procedures. Here's the timeline, dun, 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 dun." And they just love, everyone to a person in that factory just loves pointing out what they do and how good they do it. And it's just something they're very proud of. And to see that, where you go into some, I've been into places where they don't really care what's going on. They're just getting a paycheck.
Yeah.
The factory could be burning down, but as long as they can clock out, they don't care. But these people just really, so the group there, and that goes from the lowest technician up to the CEO. I mean, it's just crazy. I've had some of the most interesting discussions we've had a handful of CEOs, but each one, you have these discussions like, wow, these guys really know what's going on. So he's not just about, oh, we got to take care of our customers and our investors and our stock. It's like, no, he's very focused on, what about this, the way this machine is set up. Are you sure this is the most optimal? So everyone there is very focused on putting a good product out. Now, the second piece of that is that we have grown this team in the U.S. So we grew it from, we came to the United States in 2008, and there was 4 of us here.
Wow.
I think we sold 64 megawatts, something like that, the very first year. And now 64 megawatts is, Tuesday for us. So, but we've got a very good team. It's a very high performance team. We're still a small team. We were, 15, 16 people up until, a year and a half ago. So, and we're selling, a gigawatt of product, which no one else is doing. But the only way that happens if you're all high performers on that team, and it's a true team. So that's one of the things we've put together here at REC. We've got the right people, we got the right management, and the right product. And so that's what keeps me coming back. It's real easy to wake up in the morning and go out and support this product, because it's, great people to work with, great product, and there is altruism in this industry. I mean, we're doing a good thing. We're saving the planet one day at a time, is what I say to my wife as I'm walking upstairs to my office. If I don't go into our real office in San Luis Obispo, it's like, hey,
Yeah.
I'm gonna go save the planet, baby. So, but it is a great place to work with, and it's been good for the past 15 years.
Thanks for sharing that, George. Thank you.